Okay, everybody, we are going to look at question number 5.48, and this kind of helps us with the nature of enthalpy and what's going on here. So let's look at questions A, B, and C for 5.48. We're not going to look at part D, okay? So A, B, and C. So let's go forward. And we can take this, we can paste this question right here. Okay, so it says consider the decomposition of liquid benzene, and it gives us a reaction. Okay, so now part A says what's the enthalpy for the reverse reaction. Okay, well, if you reverse the reaction, you end up changing the sign. It becomes positive. If it's positive, it becomes negative. If it's negative, it becomes positive. So in this case, the answer to A is delta H equals negative 630 kilojoules. Okay, and so this helps us down the road if we're going to solve like a Hess's law problem, and we have to manipulate the reaction. When we reverse a reaction, it changes the sign of the delta H. Okay. Now, for part B, it says, what's the delta H of formation of 1 mole of acetylene? Well, this is acetylene here, okay? And so this gives us how many kilojoules how much energy is, in this case, absorbed, okay, not released, but absorbed, for one whole reaction. And in the reaction, how many moles of acetylene do we have? We have 3. Okay, so the answer is going to be 1/3 of this. So the answer is going to be 210 kilojoules. But I'm not satisfied with that, stopping there. What I'm satisfied with is I show you kind of mathematically what's going on too. Okay, so mathematically, this is a unit conversion problem. Okay, the reaction gives off 630, and that's positive. Positive is really the only time we use, our thermodynamics is usually the only time we use positives. And so this is kilojoules, but it's safe when we're given this delta H that it's kilojoules per mole reaction. Okay, and so now we're talking about there just being one of these reactions. We didn't put a coefficient in front of the whole reaction to multiply it, so it's just per 1 mole of reaction. Now, for every 1 reaction, there are 3 acetylenes, C2H2. And don't think I'm a wizard with naming. It says right here that that's acetylene. So, for every 1 reaction, there's 3 moles of acetylene. And so, and again, we're just using what I call the X line here to do the conversion. And so 630, here, let me bring up my calculator so you can see. So 630 divided by 3 equals 210 kilojoules. Okay, and that's positive. Okay, now it says which is more likely to be favored, the forward or reverse reaction. Now, in thermodynamics, the favored reaction, okay, when we talk about it being favored, we want to know which one is more likely to occur. Okay, well, the thermodynamically favored reaction is going to be the one with a negative enthalpy. Remember that it's exothermic reactions that are favored. So the reverse reaction has a negative delta H, so that is the one that is more likely to happen, or is what we would call thermodynamically favored. Or in this case, if we really wanted to get specific, it is enthalpically favored. Okay, that's quite an adjective right there, enthalpically. Right? Or is that an adverb because it ends in ly? Yeah. Anyways, so yeah, that's an adverb. Anyways, so that is so that's how we determine kind of what's going on with these reactions. Hope this helps clear up how to manipulate the delta H, kind of clears up some unit conversion stuff. So have a good night.